Okay, so in standard 11, we graphed equations in slope-intercept form. And so for 12, we're literally just gonna flip that around. You can already see that the lines are graphed. We are going to go backwards and pull off the equation from the graph as opposed to being given the equation and graphing it. So the first part, this is the first of 4 parts of a videos, and we're gonna talk about how to write an equation in slope-intercept form if the line is already graphed. And regardless of what video we are on, parts 1, 2, 3, or 4, the concept is going to be the same. If you can identify the slope and the y-intercept, you will be able to write the equation. And so this one should go pretty quickly because we just spent a bunch of time putting these points on here. Now let's just take them right off. So a quick reminder of let's start with what I feel like is the easiest one. The easiest thing to probably identify is the y-intercept. The y-intercept is where we begin, and it's where the line touches the y-axis at. So that's pretty easy to identify, okay? Because it's where it touches this y-axis, and that is our B, okay? So if this is our B, I just put 2 right here. If it's touching at +4, then I put it at +4 right here, okay? Now, finding slope is a little bit different. You have 3 options, and I'm gonna review all of them with you. I'm gonna start with what I'm hoping you use first because it's the quickest and the easiest. And if we remember, slope is defined as the rise over the run, meaning your vertical distance to your horizontal distance. And if we start reading a line like we read a book, we start from the left point and move to the right. So to get from this point to this point, did I move up or down? I moved down, and so because I'm moving down, my rise is a -2, okay? That's the numerator of my fraction. And because I'm running 1, then this is 1, which means my slope, I don't really need that 1 there. So once I have M and B, you guys should know how to assemble it, right? Because the equation is y equals mx plus b. So you're taking this b value, and that is where you started last time in the equation. And if it's going to be y equals x, and we really are just filling this in right here, you know the number in front of x is the slope. I found that it's -2. And if you look at it like this, if I were to say, okay, I know I'm gonna have a y equals x, and then you just kind of have to fill it in. I think we used pink for this. So this would be where we began, and this -2 would be where we moved. So let's take a look at this, keeping in mind that if most of my equations are gonna be y equals something x plus or minus something, and we really just need to pull both of those pieces of information off, put here, so that we could fill it in our equation. So let's do that for this one. So I'm starting at this point, which is +4, which I know right away, if I know I have that +4, that I can go ahead and just write the +4 right here. Now let's see what our slope is. I went up 1, 2, 3, 4, 5, 6. That's my rise. And then I ran 3 to the right. And I always should reduce slope, and 6 divided by 3, or in other words, how many times does 3 fit into 6? 2. And that then is my slope and goes here. And so my equation of this line, that in standard 11, we were given this and we graphed it, 12 is backwards. You were given the line and you had to come up with the equation. Y equals 2x plus 4. So let me just real quick show you that you have 2 other options to find slope if you get confused. I purposely put 2 points on here so that if you really were comfortable with that stack and subtract that we did in standard 10, that you could do that here. You could just take these 2 points, the 0, 2, the 1, 0, and you can do that stack and subtract to find this M value. And you would just do 2 minus 0. If you were really comfortable with this formula, 0 minus 1, that would give you 2 over -1. And it doesn't matter where the negative is. If it's anywhere, it's a -2. That was another way to do it. A third way to do it, which I saw a couple kids doing, was they were comfortable finding slope from a table of values. So they literally just took those points, and instead of stacking and subtracting them, they made an XY table. And they said 0, 2, when x is 1, y is 0. And then they did this. Remember that? So they said for every 1 that this is going up, this went from 2 to 0, so it went down 2. But the most important part about this is that you have to remember to put the change in the y value on top and divide it by the change in the x value, which means then that this -2 has to go on top and that has to go there. So from a graph, literally, I'm giving you the y-intercept. You're pulling that off. For slope, you have 3 ways. I would recommend really learning this rise over run method. If that doesn't work for you, use the stack and subtract. And if that doesn't work for you, put it in a table. So let's move on to this third example, and let's just kind of see which way kind of works for you. I'm kind of trying to zoom in here from my watch. Okay, so the first thing I'm noticing is that I have a y-intercept of +3. That's really simple because if my b is 3, then I know that I'm gonna put a +3 right here. If that was a -3 and it touched the y-axis at -3, I would put a -3. Okay, so you're gonna see me use this rise over run strategy just because it's the easiest and the most efficient to get to my friend's house. Remember, if I live here and he lives here, I have to go down 3 streets and to the right 2 streets. And so there's my slope. Once I fill in these 2 blanks, you guys, you have everything you need to be able to go ahead and write it in full slope intercept form. So I'm gonna say y is equal to mx plus this 3. Do not forget your x. A lot of kids will be so focused on getting them in the right spot that they forget to put that x in there. So let's take a look at this one. And you notice that there are, well, if you look real close, I guess you can see them. I was gonna say there's no dots, but there is one right here and one right here. But even if there weren't, we know that we are just looking for points where those grid lines meet. But notice that I didn't label the actual points like we did here. So you could pull the points off if you want, but there's always a risk of, you know, naming them incorrectly, which is just, again, why it's just super important to learn that rise over run. So from here to here, I rose up 3 and I ran 2, which means my slope is rise over run. And my y-intercept is, again, just like it was over here, a +3. I have everything I need to assemble my equations. It's like I'm getting ready to bake a cake. I have all my ingredients. Now I just need to get them in the right spot. And if you look at it as y equals mx plus b, then this +3 is your b. And don't forget that your x has to be there, and this is your 3 over 2x. So I know it might be hard to see full of color, but y equals 3 over 2x plus 3, okay? Let's try a couple more examples, and then you're... Sorry, my video stopped recording for a minute, and I did this problem before I realized that it wasn't recording anymore. So let's take a look at this one. Our y-intercept is 3, just like all the other ones were for some reason, which I put here. And my slope is a down 3, which is a -3, a rise of -3, but a run of 4. Now, eventually, you might be able to go right to writing the equation without needing to pull out the m and the b. This is kind of there to help you, but you don't have to do that. If you can get to the equation without writing the m and b, that's going to be totally fine. So we started to take a look at this one. We see that the y-intercept this time is going right through the origin. It's 0, 0, so I'm going to put a 0 there. We'll see what that looks like in our equation. My slope just looks like your traditional up 1, right 1, up 1, right 1. And so 1 over 1 is really just 1, and let's see what that's going to look like. So if you go and fill in mx plus b, you might think that you have to write this. But really what you need to know is that if this is a 1, you don't have to write it, which means every time you see an x by itself, you are assuming that the slope is 1 over 1. And if this y-intercept is 0, you don't have to write it either. So literally when you see y equals x, it really means y equals 1 over 1x plus 0. And so you can kind of see it hiding here in that. It's called the parent function, actually, and we'll talk a little bit more about that later. Okay, these last 2 examples, and we'll wrap this up. I wanted to show you, we know we have some special cases. I don't know if you can see those lines. We have a line here that's horizontal and a line here that's vertical. And we already know that there's some special things that go on with horizontal and vertical lines, and it can get a little confusing when we start to take a look at how to fill these blanks in, so follow me here. If you remember right off the bat, actually let's just start with our Y-intercept, and I know it's a little weird because there isn't an official point right there, but you know that that is still where that line is touching the Y-axis at 1, 2, 3. I don't know why I chose all these with 3. So my Y-intercept is 3, which we know it's going to be a +3, right? Now, I'm looking at my slope, and if you remember from whatever standard that was, the slope of a horizontal line is not positive because it's not going up from left to right. It's not negative because it's not going down from left to right. And if it's not positive or negative, it's just 0. So I'm actually going to put 0 there, but now how we assemble our equation is if you do it the way that we did all these others, you have y equals 0x plus 3, which is different than y equals 1x. When there's an x, that means your slope is 1 over 1. When there's no x, you don't even have to write the x, and this is how you were used to seeing that. So you could really kind of just ignore all of this and say, oh, that's a horizontal line on the y-axis. This is the equation y equals 3, and call it a day. That would be super easy to just do that. So taking a look then at this vertical one, this vertical line, you know something else is different about that. First of all, if we're always looking to find that B and that y-intercept, where is this line touching the y-axis at? It's not. It's parallel to it. So when I go to put something in for my B, I'm actually just going to write the word none. There is not a y-intercept because this isn't touching it anywhere, which already kind of makes it a little weird. So, and then if you remember, if we have a positive slope, a negative slope, a 0 slope, then hopefully you remember if this was a hill that you were trying to climb up or down, or if you remember that skateboard video, this guy's trying to do his skateboard, it's impossible. And so when we see a vertical line, we write the word undefined as the slope. And this is great information, but that sure doesn't help me figure out what to write for the equation. And so if you remember from all these other horizontal vertical lines we did, if you remember me saying that if you look at an X, you see 2 little V's, like a V for vertical. This is the only equation that you will ever start writing with an X equals instead of a Y equals. All of the other ones start out Y equals except for vertical. So vertical, and here's the thing, like where does it touch the x-axis at? So we're kind of looking for where it touches the x-axis here. This is the only time we do that. And it's touching at -1. So my equation of that line is x equals -1. And you know what? I could tell because look at both of my x coordinates. They are -1, okay? So whenever you see a vertical line, keep in mind that you are doing an x equals. So if that was the name of this line, and if I were to do this vertical line right here, I don't need to do any of this stuff. I just need to go, oh, it's vertical. It's touching the x-axis at 1, 2, 3, 4. So the name of this equation is x equals 4. Oh, hey, look, over here, I see a horizontal line. It's touching the y-axis at 1, 2, 3, -4. The equation of this line is y equals -4. And that's all there is to it. And that's how you write an equation from a graph.